Okay, so we're gonna get started, and as I'm thinking of a couple of things, because I have kind of run out of time sometimes at the end, so I'm gonna tell you some of the things I'm thinking about right now. We have a test that'll be in here on Monday of next week, all right? That test will be on Pearson, right? We'll take that test online, okay? I would allow you to create a formula sheet to bring with you. And when by formula sheet, I also mean like a StatCrunch command sheet, right? So write down the commands that you're using to get to the various things in StatCrunch. You need to, all right? I'll let you write down identifying the variables that we're talking about, okay? So an identification of the variables. The empirical rule, I would definitely write that one down, okay? And I would start keeping track of these things by chapter, because we end up with a bunch of StatCrunch commands towards as the semester moves on. And sometimes it's easier to understand those commands if you know what chapter you were using them in. Okay. You know, we don't have a whole lot of places to go to so far. We've only gone to stats and graph. So, but you know, if you need those as a reminder, by all means write them down. The only thing, the things that I do not allow on my formula sheets are definitions. So I don't want you to have any definitions of the things that we've been using or any examples, okay? So by all means, please write down those variables. It's fine with me. You're going to be using them enough that hopefully they'll be, you know, very familiar with you, but write them down. So in other words, if you wrote down mu equals the population mean, that's good. Okay, and those StatCrunch commands, formulas, those kinds of things. Okay, now I don't have it done, but I will have it done either by this afternoon or tomorrow afternoon. I will try to post sort of a practice test, all right? That's not going to count for anything, all right? It's just a way for you to practice. And I'm going to actually make it time so that you can practice on trying to complete something like that in a timed environment, all right? But I'll just let you practice it as many times as you want, probably. And those are, you know, just questions to help you think. How fast can you answer those questions? Those kinds of things, all right? So I'll just let you attempt that multiple times, but do consider that you have a finite amount of time here in the classroom, right? We only have 80 minutes in the classroom to complete this test, all right? So you need to know the material and know the StatCrunch commands and know your calculator with enough familiarity to be able to make it through the questions in time, okay? So that's what you're practicing on this weekend, in addition to the homework that you're going to be finishing, obviously, okay? The test is going to have somewhere between, I would say, 35 to 40 questions. I'm in the process of making the test still. I would expect out of those questions that you can have anywhere between 5 to 10 short answer / essay type questions. Now, my essay questions are not in it like an English essay by any means. It's more of a, you know, short answer, maybe 4 to 5 sentences to help explain what it is that you're looking at. All right, that's what I'm talking about when I say like an essay type question. All right, so you still will have some of those in there. Okay. Questions that I haven't thought of to talk about for this test. Remember, this is covering chapters 1 through 3. So we're finishing up chapter 3 today. We're finishing up 3.4 as well as 3.5. Did I forget anything? Yes, ma'am.
When we turn in our little, not cheat sheet, but the little sheet that we have with the
yes, but I'll give it back to you. Okay, and that's a good, you're asking if it has, you know, our little, right? Our little, so I don't really care what size paper you have. Okay, so one sheet of paper though, I do limit it to one sheet of paper. I don't want to have a whole book when y'all come in here, okay? So Good question. Any other questions that you can think of? So yes, you will have to turn in, and you want to make sure that you're kind of trying to show your work, right? If you're doing some sort of frequency table, all right? I don't want you to spend time writing a bunch of stuff down, but if you have calculations that you're making, it's helpful if you will write those calculations down. Okay, if you're having to do those, then you can kind of check your work. Anything else? No? Okay. Well, if you think of something in a little while, just ask me. So here is the notes that I handed out the other day. If you were absent, there you go. They're right there. I had them in my notebook, so you can come up and grab them. All right. Now, remember when we were talking and when we ended class last time, we were talking about a z-score, okay? A z-score. And our z-score tells us the number of standard deviations away from the mean that we are. Remember that, right? The number of standard deviations away from the mean. And we could talk about that. We did that example where we were talking about the baby's birth weight. Remember that, the preemies and the full terms? And we standardized the weight so that I could then compare them. Do you remember that? Yeah? Okay. So that's the point of a z-score, is to standardize the data so that we can rescale basically our distribution. Remember the middle of a z-score, right? The middle or the mean of our z-score, when we standardize it, becomes 0, and then we just move to talk about 1 standard deviation above, 2 standard deviations above, and so forth, okay? And what type of data, since I'm talking about a mean and a standard deviation, what type of data would we normally be looking at if I was describing the distribution? What shape would I be looking at? Normal distribution only. Normal distribution, right? We don't use standard deviation and means or z-scores on skewed data. Right? We don't do that. So how do we go about talking about things that are skewed? Well, that's when we talk about quartiles. In essence, we can talk about percentiles as well. So quartiles are exactly what they sound like they are. Okay? Quartiles are us dividing our data set into quarts. Right, so if I thought about quartiles, I would think about 25% of the data, 50% of the data, 75% of the data, or 100% of the data, right? That's dividing something out of 100 into quarters, right? Quarts. And we have special values that are associated with those quartiles. So if I have a data set that ranges, right, in order from the largest to the, from the smallest to the largest points, then I can also talk about that data. And the first quartile is going to be considered Q1, because they're not really original values here. Q1 would be for the first quartile. Q2, which is what we also consider the median, would be the 50% quartile or 50% mark. Q3 is 75%. Okay. These values all come from, you can find them really quickly by looking at them in StatCrunch, or we can also do them by hand. Okay, let's look at an example here together. So I have Old Faithful geyser. And I want to determine what the quartiles are from this data set. All right, I want to determine what the quartiles are from this data set. So you can see here that I have the numbers. Let's see, how many eruptions do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 10 data points here for Old Faithful eruptions in Yellowstone. And I want to know, I want to find the quartiles of this data set. So when we find the median, what was the thing that we had to make sure our data set was, how was it organized? It was ordered, wasn't it? Okay, so when I found the median, I had to order my data set, right, to find the middle value. So when you're finding quartiles, you also have to make sure your data set, if you're doing this by hand, is also ordered. In this particular case, it is not ordered, is it? All right, so let's order this data. Then we'll kind of look at how we go about finding the quartiles. So let's write the data down on our paper here. We're going to start with 110. I want everybody to write the data down ordered on their paper. Okay, so I've got the data written down here, ordered from least to greatest, and that's just the data that you saw above. Now, if the first step in finding the median is to order the data, how will I find the median of this data set? The middle, right? In the data, the median, the middle of the data, there's 10 values here. So on an even number, I'm going to go to the middle, which would be 1, 2, 3, 4, 5. Because I have 5 to the left of that bar, and I have 5 values to the right of that bar. So that means that I'm directly in the middle, right? There's no number there. So I have to find the median by taking, what, 245 plus 251 and divide it by 2. In other words, what's the middle value right there? And that would be at 248. All right, so we found the middle of this list, right? That was what the median told us. 50% of the eruptions of the data for Old Faithful, 50% of the eruptions are going to be times greater than 248. 50% of the eruptions would have a time less than 248, right? That's the middle. It says 50% is more or 50% is less. We just simply went to the middle of those values and found out what the number was in between them. Now, if we come over here and we start looking at the first quarter, right? The first quartile, which is at the 25% mark, we're basically going to look at these 5 values to the left of the median. And those now we're going to treat, what's the median, right? What's the middle of those 5 numbers? 234 is an odd number, right? It's an odd set, so that one should be fairly easy. So 234 is going to be Q1. Then I can go above the median. I have a data set up there I could kind of concentrate on. What's the middle of those numbers that are above the median?
259.
259, very good. So that's Q3. We have down here at 110 our minimum value. We have here at 278 the maximum value. And so now I have my quartiles and my data set kind of arranged in this percentiles, if you will. Okay. Here at Q1 at 234 minutes, I believe that is, right? That's the 25 percentile mark. So 25% of the data is going to be less than 234, right? How much data is going to be greater than 234 in terms of percents? Right, 75, right? Because the whole thing is 100. 25% to the left, 75% to the right. Okay, up at Q3, we have 75% of the data is going to be less than 259 minutes. 25% of the data is going to be greater than that. Okay, the only thing you have to consider when you're talking about percentiles is I like to think of it as I'm always going to be reading those percentiles starting with the left value being 0. So I'm going to read it increasing from the left to the right. Okay, I'm going to read it increasing left to the right. Now, although I know I can speak to Q3 as having 25% of the data being more than that, conversely, I would say 75% of the data is less than that. Okay. And it really just kind of depends on what you're trying to answer, right? How you want to talk about the data. The other thing that we would think about, so does everybody understand how you find these quartiles? Start by finding the median if you're finding it by hand. Start by finding the median. Move to the left of the median and find the middle of that data set. Move to the right of the median and find that data set. Okay? We can choose all of these values in StatCrunch. It will automatically generate them for me under the summary stats values. Now, when we think about skewed data, remember that the median is a measure that is resistant to outliers, right? Remember the median, it doesn't care if I have really large numbers or really small numbers because it doesn't change. It's still going to be the middle of that data set. The 25 percentile, the 75 percentile, they're still going to be at their locations regardless of very large or very small numbers, right? Think of these percentiles as just a location in a data set, right? It's just a spot in a line of numbers, okay? So if in a normal distribution, we use the standard deviation to talk about how spread out the data is, that's the point of the standard deviation, and it only applies to normal distributions or bell shapes. When we look at skewed data, we want to have another way to talk about how spread out the data is. And we typically do that by referring to what we call the interquartile range or the IQR, which you can see here. Okay. So the IQR, which again we call the interquartile range, is found by taking the differences between Q1 and Q3. All right, I'm going to take the difference between Q1 and Q3. So the IQR here for the data set on our geysers is going to be Q3 minus Q1. Remember, subtraction is specific, order is specific. I don't really want a negative number here. I just want to know what is the range, how much territory is in that middle value there. So I would take 259 minus 234. Those are the minutes that encompass the middle, the Q 75% and the 25%. And when I do that, I find that that value is what? What is that value? What is it? 25. 25? Okay. So what the IQR tells me, what the interquartile range is telling me, is that 50% of my data, right? 50% of my data is going to have, there's going to be a range. The difference between the smallest value in that range and the largest value is 25 seconds, if that's what we found, right? 25 minutes, I mean to say. All right. The IQR is the middle 50%. Because it's 25% for Q1 and 25% for Q3. It's the middle 50%. So 50% of the data will have a difference of 25 minutes, right? There'll be a difference of 25 minutes for 50% of our data. I think I finally said it right. Okay. 50% of our data will have a difference of 25 minutes. Think back to the empirical rule. What percentage encompasses our one standard deviation from above and below the mean? 68. So that's kind of the comparison, right? So in a normal distribution, we talk about one standard deviation above or below. And that's going to be 68% of our data. For a skewed distribution, we talk about it in terms of the IQR. 50% of our data is going to come within, the lower Q1 up to Q3. 50% of it. That's the comparison between the two. And we do that again because when we're talking about skewed data, right? These percentiles and median are resistant to those very large and very small values. Standard deviation and mean are easily influenced by very large and very small values. So we just have to have two different ways to address distributions, because we know that sometimes we have normal distributions and sometimes we have skewed distributions. So how do I handle both of them? This is how you do it, okay? All right, so the interquartile range is what we kind of use to talk about the middle. And here is, and I didn't run this for the Tampa Bay, but the concept is the same. Remember, because all football salaries really distribute this had the same distribution here. So this was for 2014 Denver when they won the Super Bowl, and Peyton Manning, I believe, was the quarterback at that time. And so all I did here, all I'm really showing you here is these values, the min Q1, the median Q3, and the max all constitute our quartiles, right? It's going to be what we call our 5-number summary in just a second. All of those values came from StatCrunch. Remember how I told you that you could hit control and then individually select the statistic that you wanted to show? If you select them in the order you want to see them, right? Scroll through the list and select them so that it comes out as min Q1. So that's the exact way that I selected them so that it spits it out the way that I want to see it, okay? So just highlighting them as you go through the list is going to not put them in, it'll put them in the list that it'll put them in the order that they appear in the list, as opposed to the order that you maybe want to see them. And then you can see that StatCrunch will also calculate for us that IQR, right, the middle 50% of a data set. Okay, are there questions on that? Now there is a way, and I kind of want to address it once you're looking at the worksheet that I gave you. So we'll just answer this question kind of quickly. Turn it over to the back if you're not already on the back. Oh, you had the list on yours, didn't you? I must have put it on your notes. Good for me. Yeah, did you? Okay. So question number 4 there says, explain the meaning of the following percentiles. The 15th percentile of the head circumference of males ages 3 to 5 months of age, anyway, that old is 41 centimeters, right? All right, so think about that for just a second and see if you could explain to me, interpret that to me. If you had kids and you take those kids to the doctor, right? Then as they are infants and they are getting larger, they're always, when you go in for their checkups, they're always plotting that along there, right? My kids are always in the lower percentile because I'm a short person, right? So, but this is the same scenario, okay? So kind of put yourself in that scenario, if you know what I'm talking about. See if you could come up with a sentence that would explain the meaning of question 3A. It doesn't have to be anything fancy. A lot of times we just regurgitate the sentence that was given to us.
So it's like 15% of males 3 to 5 months have a head circumference of 40.
Or less, right? Yes. Did you hear what she said? You hear what Erica said? Okay, 15% of 3 to 5 month old males have a head circumference of 41 centimeters or less. Anybody want to try it a different way? If I'm in the 15th percentile, my child is in the 15th percentile, what else does that mean? 85% of them are greater than that, right? Okay, so it just depends on how you want to state it. You could say 85% of males 3 to 5 months, years old, that age have a head circumference of greater than 41 centimeters. So let's look at the next one then. Somebody else take a stab at that one.
90% of females to age waist circumference of 80.7 centimeters.
Right, 90% of females with a waist, 2-year-old females with a waist circumference of 52, that is 52.7 centimeters or less. I think I just read that right. How else would you say it?
Males aged 2 years of age with a waist circumference is larger than
10% have a waist circumference that's larger than that, right? Okay. It doesn't, both answers are correct. All right, this depends on what it is you're trying to say. Okay. A lot of times you'll see percentiles like this on standardized scores. So if you've ever brought home the sheet that says where you landed in the standardized testing that was taking place for that particular grade, that's how they state it also, right? It's a percentile moving from the left to the right. So if you're in the 60th percentile, right, that means 60% scored lower than you, 40% scored higher than you. Okay, that's how you would interpret that. Now there's a question on there. And we didn't really talk about this. I think it might be, let's save that question about outliers for just a second. Okay, we'll come back and we'll visit that one again in just a minute. So now we want to talk about, that's 3.4, right? Our measures of position. Measures of position meaning z-scores. Where is my data point positioned in relation to everything else, right, that's on there? And if I can't use a z-score because it's not a normal distribution, then I would be talking about a percentile or a quartile for skewed data. Now, let's turn our attention to section 3.5, which is about the 5-number summary and box plots. Can somebody tell me what the 5-number summary is? All right, so it's the mean. Excuse me. It's the min, not the mean. It's the min.
maximum.
All right, the maximum. Q1, Q2, and Q3. Q2 is the median. So yes, Q2 is the median, right? So it's the min, Q1, Q2 are the median, and Q3 and the max. That's considered the 5-number summary, right? That was the set of values I was showing you a minute ago on our picture. All right, and the 5-number summary is actually what we use to construct a box plot. You don't have to write this down. In fact, if you've got a picture, just take a picture of it for me really fast so you can follow along. Because I'm never going to ask you. No, maybe you should. Maybe you should write it down. I lied. You can take a picture if you want, but I think you should also write it down because you might need to know it in just a minute. Okay, have you got that? So this is how you draw a box plot. From previous classes, generally in high school, or I think they might have started doing this in middle school, I'm not really sure. You may remember what a box plot looks like. Algebra 2, that's what I'm trying to think of. I believe that they started covering this at least in Algebra 2 within the last 10 years. Box plots, have you heard of the box and whiskers? Right, ever heard of those terms? So what a box plot does for us, and this is just the instructions on how you draw it. We're going to draw one together. A box plot is a graphical representation. It's just a different type of a graphical representation. It's a graphical representation that allows us to identify that middle 50% of our data. It also, when we grow the whiskers out, all right, it allows us to identify outliers, okay? And so it's just a really quick way for us to be able to identify those things. And we're going to practice today kind of interpreting those box plots, but I want to show you, we're going to actually make one up in just a minute. We're going to construct one, I should say. So you draw the axis, then you draw your lines that represent the Q1, median Q3. Those become the box. Then you calculate the fences. So you can see here the fence is calculated by taking 1.5 times the IQR and subtracting it from Q1. It's going to give our left or our lower fence. And then if we add that value to Q3, it gives us the upper fence. This will all make sense in a minute. And then we find that value and we draw a line, a horizontal line out to that value, and that becomes the whiskers. And that's kind of a fence. And any data that falls outside of that whisker, or that fence, I should say, is how we identify outliers. Okay? All right, so did I talk long enough for y'all to be able to have that written down? Okay, you can come back to it in a minute. Let's do something here, because maybe it'll be have a little bit more relevance. And I want to draw a box plot for our height. Remember when we calculated when we took our survey, and we all had to put our height in? All right, so I'm going to show you how we can find because in order to construct your box plot, you have to have the 5-number summary. The class survey. Oops. So we see here we have our column for height on the left-hand side. Remember that? So I've got my data. What type of a variable was this considered? Quantitative or qualitative? Quantitative, you all said, right? Quantitative, you said? Okay, very good. And I want to know what the 5-number summary is. So I'm going to come here to stat, summary stats, column. We keep using that, don't we? Okay, so it'll become familiar, I think. I'm going to do the summary stats on the height column. So now I'm going to come down here, and this is where I said we're going to pick our values in the order I want to see them appear. So what's the first value I want to know in that 5-number summary? The minimum, so I gotta come down here, I'm gonna choose minimum, and then what am I looking for? Q1, so it's here, then what? Median, good, then what? Q3, then what? Max. Okay, did I pass the max already? Yep, there's the max. That's the 5-number summary, isn't it? Okay, and so I'm also gonna put on here, because I'm gonna need to know the IQR, so I'm gonna put that on there as well. How do I find the IQR by hand? Q3 minus Q1, right? Q3 minus Q1. So here we go. Here's my summary stats for our height. And y'all can write that down as well. So let's use that to draw our box plot. Now the box plot says that I am going to use Q1, the median, and Q3, and I'm going to create a box around those numbers. Okay, so these numbers, think of a number line, right? So if I were to have all of these numbers on a number line ranging from 5 all the way up to 148, is technically what we're talking about here. So I'm going to just draw it kind of like this. Here's my box. Q1 is going to be at 62. Q3 is going to be at 68. And the median is closer to Q3, is it not? It's closer to Q3 because it's only 2 units less than Q3, correct? Does everybody see that? Okay, so I'm going to put the median kind of over it, closer to Q3 because it's at 66. So if I'm thinking of a number line, 66 is closer to 68 as opposed to 62, yes? Okay. Now, I need to draw my fences. So the fences are going to come from the left fence. So moving to the left is going to come from Q1 minus 1.5 times my IQR. So Q1, which is 62, minus 1.5 times 6. The IQR was 6, right? Okay, so somebody do that math for me really fast. Did y'all do it? What did you get, Mom? You just switched you subtracted it in a different order, but you got 53 what? All right, she's saying 53-ish. What do y'all get?
That's what I got too.
So what are you saying? I couldn't hear. 53, just even?
Yeah.
Okay, I was thinking in a decimal. 53 inches or 53, okay? Just 53 is what I'm trying to say. Right fence is going to be Q3 plus 1.5 times the IQR. 68 plus 1.5 times 6. What do we get there? 77. Okay. So those are the numbers that we're going to come in here and we're going to say, okay, so we have a fence here that's growing out to what we would call 77. We have a lower fence, which we're going to grow out in this direction to 52. 53, excuse me. Now, I have a minimum number here at 5. Now, what we would normally do is we would go back and we would look at our data set. And our data set, if I'm scrolling through these numbers here, 5, 148, it would be better if I ordered this list, but I'm not going to do that right now. There's a value at 148, and there's also a value at 5. What was the right fence? What's our fence on the right?
77.
77, okay, because I saw a 74 here, and I was wondering if that would play into it. So what you would do is you would come here, and we have one value. 148 would be way out here. That would be 148. And we have one value way out here, which would be at 5. Okay? And everywhere there is a data point outside of the fences, we identify it. All right? We identify the points that are outside of my fences. And what we see is that when I fall outside of these fences, I can quickly identify values that may be outliers. Okay, they might be outliers. So what we have here is we have 2 values that appear to be outliers. And the way that we handle those is we go back in and we might want to take a look at the value that was entered. We talked about this the other day when we had it up there, right? Where if I go back in and I look at that data set, although I don't know, I can't speak for the entry from that person, we can kind of start thinking that that person put that in there, meaning 5 feet as opposed to 5 inches. That would be a safe assumption. But you can leave it in there, or if you think it might be a data entry error, then you would just remove it. You wouldn't change it because you don't know what it was really meant to be, right? Maybe they slipped and they didn't get the 6 in there, right? I don't know. So let's just say safely remove it. The 148, I would say, is also an outlier, okay? I don't know why that one isn't in there. Can't think of a reason for 148, but it's not a logical value that would be in our data set. So a box plot like this allows us to look at the data and quickly identify outliers. Now, one of the things that you want to consider when you're looking at box plots is in the box, since we have the middle 50% here, when the median is closer to one of my sides, all right? If the median is closer to either Q1 or Q3, it's an indication that your data is skewed, okay? The median is showing us, so in this particular case, it looks as if our data is skewed. If the median is shoved further to the right, if the median is shoved further to the right, then my data must be skewed left, correct? Let's see what this looks like, the histogram. So if I were to graph, and let's change it. It almost looks like it could be somewhat symmetrical, is what it's almost looking like. Let's look at the box plot for it and see where that flies in here. So our box plot can be found by going to graph and box plot, fairly intuitive in that way. But there is something we want to do here. I like looking at my box plots horizontally, okay? That's just it's kind of the way that we normally see them. And it's already defaulting to using the fences to identify the outliers. But I do want to look at it horizontally, otherwise it'll graph it vertically. Okay, so I just like looking at it horizontally. And I do kind of want to show these just so you can see what's up there. So see how it squished it up? Why do you think it had to squish it like that? Because 148 is so much farther out from our fence of, what did we say that fence was, 70 something, right? And 5 is so much farther out than our lower fence, right? So it kind of had to adjust them. But you can see that our box, so the mean and the median are actually, I would say, kind of in the close-ish to the middle in this one. And you got your fences there. So let me show you. This. And this is what we want to start talking about and we want to look at. So again, this is the data for our football players that I used for the 2014. Same thing here. If we were looking at this distribution from the histogram up here, we can see that that histogram is showing that we have a skewed right distribution, correct? Okay. And we can also see that those tall bars that are on the very far left, right? What does the tall bar imply? How much data is in there? How much? A lot, right? Lots of data is in the tall bars, not many data, not much data is in the short bars, right? Okay. And so we kind of know that here. The box plot, you can see the box plot. And do you see those 1, 2, 3, 4, 5, 6 dots that are outside of the fence? The dots represent the individual data points. So they're actual data points that are falling outside of the majority of my data. That's what the fence is about, right? Because it's 1.5 times above my 75th percentile, or 1.5 times below my 25th percentile, right? So we have that range. It's kind of like, well, never mind. So we have the individual data points that show up here. Notice that if you're just concentrating on the box plot itself, you're never going to see individual data, right? It's more of a summary of the data. When you have the fences drawn, and you have to draw fences to identify these outliers. If you don't draw the fence, try it sometime in StatCrunch. If you don't draw the fence to identify the outlier, it's simply going to extend it out here to encompass the range. So it would show you the range of your values from here all the way to the left-hand side, okay, with no fence. The fences are what helps us identify the outliers. So with no fence, you basically are drawing something all the way from the min value up to the max value, okay? Now, some other things to consider. How well can y'all see this on the back row? Shelly, can you see that pretty good on the back row? Okay, can y'all see? I'm gonna go that way. Does that help seeing the bottom of it a little bit? Yeah, okay. Now I'm gonna make that a little bit bigger. You all can envision that the leftmost bars over here are really tall, right? So now I want you to look at the shape, or I want you to look at where the box, right? Where the IQR, because this box represents the middle 50%. Q1 is the left edge, the median is in the middle line, or is the line in the box, and Q3 represents the right edge. Tell me, where does that box fall in relation to the data, to the range, or to the fences, we'll even call it? Is it directly sandwiched in between the two whiskers? It's not, is it? It's shoved over to the left, isn't it? Okay. That means when you just look at a box plot, that is an indication when the box is closer, when the box is not in the middle of your whiskers, it's not symmetrical, right? It would not be normal. So when my box is over here to the left and the whisker is more to the right, we end up with, that's a way for us to identify this as skewed. Right, okay? Another way for us to identify that this is skewed is that where the median falls in the box, so this vertical line here is also pulled to the right, okay? It's pulled to the right. So when you're noticing this box here, it's kind of counterintuitive, or maybe not, maybe it goes up with there with that. So notice that the width of that, that bar, well, I'll call it a bar. So in between Q1 and the median here is really kind of skinny, right? That indicates that there's a lot of data there. It goes along with the fact that there's a lot of data all right in that area. So it is kind of counterintuitive to what we've been talking about. This here, this kind of fatter value here is representing the rest of that data that's up there. So it's kind of a little more spread out. So the skinnier the thing, the skinnier the box, all right, shows that I have more data in it. It's going to represent taller bars on the histogram. The fatter the box represents less data on our histogram, okay? So to summarize that, we could say this. When that box shows, if our box is in the middle, or I mean the box shows the middle 50% of our data no matter what. So on a number line, generally that's what we're looking at, right? I could tell where the middle 50% of this was falling at, because you're usually going to identify the left and the right edges, okay? It does show us the skewness of our histogram, okay? If y'all don't have that written down, I highly suggest that you write that down. And then it highlights outliers, right? Our whiskers help to highlight the outliers. Now, when I compare box plots, if I'm trying to interpret, I guess I should say, not compare, but if I'm trying to interpret a box plot in relation to what I already know about a histogram, the smaller the whisker, the taller the bar. The smaller the rectangle, the taller the bar. When I have a large section of the rectangle, I've got short bars. When I have a long whisker, I also have short bars. All right. Questions on that? Make sure you get that written down, because now you're going to have an opportunity to practice interpreting box plots, okay, on the paper that I've given you. All right. So as you're finishing writing that down, I want you to get out the handout, or I want you to turn the handout over. The one that the one that I handed out to you today, it's actually on the front. Sorry, it's on the front. We have two questions at least on the front. See if you can answer those two questions for us really fast. Okay, and it looks like most of you are logged into StatCrunch, or excuse me, you're logged into the computer. So you should be able to answer questions 3, 4, and 5 as well. Let me make sure that you have the data set available. The data set for questions 3, 4, and 5 is in our shared group, and it's called 3.5 classwork, all right? Now, I don't really have time because we're gonna try to get to that stapled paper that's in there as well. So it would be enough for you to be able to just construct the box plots and all the calculations. You don't have to sketch them on the paper, but make sure that you can interpret them. So I'm gonna give you about 6 or 7 minutes to try to complete this part of the activity. Then we'll go over the answers before we move to the last part. What about you? Yeah, you're answering all the questions.
How do you do that? I've never been able to find it.
Okay, so go to that. And then the website. So that'll take us to each go to groups. And the only other do is one. So type in FA space. So that's us. And then join. So now, if you go back to click on the groups. Now when you come in, you just click on my groups this time, and it'll show up.
Okay, thank you.
3.5 class.
I was trying to.
Oh. Did you get it, Michael? Back there. They're in the back. Y'all came in, they're in the back. Sorry. That's okay. These So the data that's in the section 3.5 classwork is for questions 3, 4, and 5 on your paper that I handed out. And you don't have to sketch the box plots. In the interest of time, I just need you to be able to interpret them.
And then
Were any of y'all sitting here?
My mom was in the bathroom.
We could help Jennifer out. Doing some of her homework. Couldn't you?
Be nice, isn't it?
make it so where the histogram directly above. And then it kind of supports. So we have to do that from summary stats. Two places to go to. Summary stats gives us the summary stats gives us the 500 summary. And the graph can give us the box plot. Okay. Okay. Any question?
Just draw a line.
Where's your fence? Where did your fence come out? You can see how this has got a 3 up here. See that blue 3? Click that. The box plot. You can hover your mouse. And then it down to 79, right? So the canes are right there, right? I don't. Oh, so you drew an asterisk.
That's what's identifying. So see, that is outside of the fence, that's an outline. If you don't see that, then you're on. Okay.
Good. All right, let's go over some of these answers together, okay? So we don't run out of time. For question number 1, you had, you have that box there, right? Identify the shape. You all see that that shape would be skewed right. Everybody see that? Okay. We would say, so if I asked you to describe that or to justify your reasoning, what I'm looking for is that you identify it correctly, that it is skewed right, and tell me why you believe that. The median is to the left of the center in the box, and the right line is substantially larger than the left. Those things would justify your answer for me on a test, okay? Don't just tell me it's skewed right, you won't get credit for the whole question. You won't, get a little bit, but not everything. Determine the 5-number summary, which starts with the min, Q1, median, Q3, and the max. So 0, 1, 3, 6, and 16, approximately. I realize that, it's kind of estimating there. So if you're close, that would be fine, okay? All right, let's look at, and are there questions on that? Oh, I forgot to answer your question. I'll go back there in a minute, okay? All right, let's look at this one here, side-by-side box plots. Okay? And I would encourage you to practice some of these as you prepare for your test. So practice some of them vertically if you get to create some yourself, just in case you have a question for some reason that shows it vertically. So in this, to the nearest integer, what is the median value of x? The median comes from that line that's in the box. So, maybe 16. Good, that's fine. So approximately, right? So 16, 17, 15, somewhere around there. We're good, all right? Because it's just an approximate. To the nearest integer, what is the third quartile for variable? The third quartile. I wrote Q1, but Q3 should be about 34, correct? Okay, for our Y guy. Which variable, X or Y, has more dispersion? Which one is spread out more? Y is spread out more, right? It has a broader range. The span of the lines, in other words, right? From the min to the max is the greatest, has a greater value, I would say there. And we know that the IQR, or the middle 50%, is also wider. So those two things would be in that. Does the variable X have any outliers? That's that asterisk that you see up there. So yes, it does have outliers, and it's occurring at about 30. Describe the shape of variable Y. Skewed left. The median is to the right of the center, and the left line is substantially longer than the right. Remember, that's kind of what I'm looking for in our essay questions if you had one about this.
Question, for C, I had that it was a larger rectangle and longer whiskers. Would that be acceptable to you, or does it need to be?
Larger rectangle, longer whiskers. Yeah. We're just working on, yeah, I think that'd be all right. Okay, we got that? All right, let's move on then. If we wanted to look at the M&Ms, all right, explain why the box plot and the quartiles confirm the distribution. So I have my five number summary, the box plot, and the histogram all came from StatCrunch. Okay, I'm looking for, you can see that Q1 is the median. From the summary statistics, you can see that Q1 is median of the bottom, the middle of the bottom 25. And Q3 is the median. This implies symmetry in the data, which is supported from both the histogram and the box plots. I think what I'm trying to, or I don't even know if I wrote that or if that was in the solutions. But what you're trying to look for just from the number summary would be, is your median, like if I'm just looking at numbers, does the median fall roughly in the middle of your, is it equidistant, right? Are the values to Q3 roughly the same as the difference to the value to Q1, right? That would support it, right? Also, is the value of the median up to the maximum and the value of the median down to the minimum about in the middle? That's kind of what it's talking about, okay? That's what we're saying right there. How about the inauguration, age of the inauguration? Did y'all get to that point? Yes? Okay, so we know that the 5-number summary is listed up there. We can have StatCrunch create the box plot for us at this point. We can see that the median is in the center. Horizontal lines are approximately the same. So we would say that this would be a somewhat normal distribution, even though it has an outlier out there. Okay, that doesn't mean that it is automatically skewed. Okay, it just means that, yeah, there's an outlier out there. Okay, but overall, the box is sandwiched roughly even in between the whiskers. The median falls roughly in the middle of the box. So those two things are implying that it's a normal distribution. And then when we are looking for the pulse rate here, so I have my box plots over there on the left-hand side. And we would probably say that both of those would be skewed right. Skewed right. Okay, both of them appear to be skewed right. Okay, then if you looked at the histograms appear to also be roughly skewed right, so they support that. And then who has the larger, which gender has the larger spread? I think the females do, don't y'all?
In the box plot, it looks like the
Oh,
male, but
yeah.
from Instagram, it looks like the female.
Yep, if you look at the minimum versus the maximum, 60 to 124 for the females. Right, that's 60, 56, and I still think the females have the larger split.
Do we include outliers when we're talking about spread?
I think you do, because that would be the minimum and the maximum. Okay. Okay, now, the last thing I want to talk to you about is, and I don't have any more time. So instead, I want you to take the handout that I gave you, and I want you to turn it over to the very back. And down at the bottom, I'm going to give you the answers to this. But I highly encourage you to see if you can practice it on your own. But I'm going to have you put the answers on the back so it'll be harder for you to see it, okay? All right. So for this activity, yeah, I have it right there for y'all. Histogram B goes with variable 3. Histogram C goes with variable 4. Oh, wait, that's wrong. I lied. Start over. Histogram B goes with variable 4. Histogram C goes with variable 5. Histogram D goes with variable 2. Histogram E goes with variable 3. And histogram F goes with variable 6. Okay? And box plot 1 what are we looking for? What are the features, distribution? I don't think that'll be too hard for me to explain to you. That one is all right, but I want you to understand what I'm asking you to do on activity, on the histogram activity. So that would be this part right here, right? That would be this thing right here. So what you're doing is you're actually taking, there are 6 variables there, okay? 6 variables there, and for each variable, you get the mean, the median, as well as the standard deviation. And you have to determine which one of those variables would you match to the histograms that you see there, okay? That's what you're being asked to do on that particular one. All right, I think you had a problem that was similar to that in your homework, so this is again good practice. All right. So, like I said at the beginning of class, I will post probably tomorrow afternoon